Alright guys, so now we're going to be looking at our half angle properties, and these are going to be very similar to what we did with the double angle properties. There's going to be just a few slight differences because the actual formula looks different. To start off, we're just going to take one of these formulas and we're just going to simplify it. Okay, so if we look at our formula chart, there's a formula that looks just like this first expression. That's the square root of 1/2 times 1 minus the cosine of x. And then on my chart, that is the same thing as the sine of 1/2 x. The only difference is instead of an x, I have something that's replaced it, and it's that 4a. So where the x would be, I'm going to replace that with 4a. And remember, this entire thing is what I'm taking the sine of. So I can simplify that to just the sine of 2a. So then the last application I have here is actually something just like what we did with sum and difference properties and just like what we did with our double angle properties. It gives me some information about an angle. It doesn't actually tell me what the angle is, but I can use this information to solve my question. So it tells me that the cosecant of some angle is 13/5, and it tells me that that angle is in between pi/2 and pi, which we know is going to be in the second quadrant. My hypotenuse over opposite is 13/5. I can do the Pythagorean theorem to get my missing side, and because of where it's located, it needs to be a negative. So now that my triangle's filled in, I can use the information on that triangle to solve for the sine of 1/2 x. So I'm going to copy that formula that I have on my chart. I've got plus or minus the square root of 1/2 times 1 minus the cosine of x. And what I'm going to do here is I'm just going to replace the cosine of x. So the cosine of x is going to get replaced with my adjacent over hypotenuse from that triangle I just had. And adjacent over hypotenuse here is negative 12/13. So that replaces the cosine of x. So now what I'm going to do is just simplify the inside here. 1 I'm going to rewrite as 13/13 because I have a common denominator. Minus negative becomes plus. So this becomes 1/2. I'm going to add those two fractions. I'm going to keep the denominator and add the numerators. So that's 25/13. So this gives me the square root of 25/26. And if you guys remember with square roots, you're actually taking the square root of the top number and the bottom number. So the square root of the top number is just 5. And I'm going to leave the bottom as a square root of 26 because that can't simplify any farther. So there's my sine of 1/2. So now we're actually going to go and we're going to do the cosine of 1/2 of x. And again, it's going to be done the same way, just a different formula. And in fact, the formulas are almost the exact same. It's just instead of 1 minus cosine, it's going to be 1 plus cosine. So I'm going to replace my cosine of x with the cosine of x, which we just found in my last question was a negative 12/13. I'm going to rewrite 1 with my common denominator, which is going to be 13/13. So I end up with 1/2 times 1/13. Multiply across the top and the bottom. So I get the square root of 1/26. I know the square root of 1, so I could rewrite this as 1 over the square root of 26, and that's my cosine. And then finally I can do my tangent exactly like I did previously. If I wanted to, I could just use that formula. Any of the three that are on there would all give me the same answer. Or I can make this even simpler by following what I did the last one on my double angles. I know the tangent of 1/2 x is going to be the same thing as the sine of 1/2 x over the cosine of 1/2 x. And I just found both of those. So that means my tangent is going to be 5 square root of 26 divided by 1 over the square root of 26, or multiplied by the reciprocal. And that whole thing is going to simplify to just plus or minus 5. And that's all we have for double angles, or for half angles.